Hi YouTube and happy Tuesday. In tonight's video, I would like to show you the Casio Pocket Viewer SDK or Software Development Kit, which also includes an emulator of the Pocket Viewer. This is available in the link to it is available in a GitHub repository. It only runs on Windows, so it took me some effort to get to this point. I had to update my version of Wine from what's available with Ubuntu to the newest version of Wine through the Wine HQ repository just to be able to install the SDK as well as to run it. I'm going to go ahead and take you through the installation process and just look at what comes with the SDK as well as the emulator a little bit. Again, this is all in Windows emulation, and it would be great if I would be able to recreate the pipeline using something like IA16 ELF 16-bit Intel architecture, GCC cross-compiling or something like that. Okay, so with that, I'll go ahead to my Casio Pocket Viewer directory, cd to Casio PV SDK. I downloaded the SDK as a executable self-extracting archive. I had to first extract that into the Casio PV SDK folder. I'll now go there, cd to disk 1, and execute setup.exe with Wine, which hopefully doesn't cause any video stutter or other issues. I'll just take a moment here. Okay, and there's Pocket Viewer SDK. Yes, I agree to the license agreement without really looking at it. I will agree to that destination folder for the simulator and SDK libraries, and also for the LSIJ C compiler. Okay, I'll go ahead and agree to that. We get that nice familiar Windows 95, Windows 98 installation process. I'll go ahead and finish that, and then press enter here. Let's go to the Wine directory in my home folder. Go to the emulated drive C. Go to Casio first, PV2ENO2, PWD, and let's look at readfirst.txt. Maybe I'll do gedit. Oh, I don't have that. What do I have? Featherpad, read first. There we go. Okay, I technically meet all these system requirements, but it's I guess I'm just moving the camera. Not a super useful point of reference because I'm running this in emulation. So who cares about that part? Okay, so I'll just go ahead further down here. I'll just point out LSIC, that's the C compiler, is a registered trademark of LSI Japan Corporation. Very cool. Okay, so within this Casio PV2 XXX SDK, there's C programs, documentation, binary files for simulator common header, definition files, link information files. I wonder if I can recreate all this in a format that's usable with Linux, if someone hasn't done that already. I saw there's a libpv for PV communication. If it's possible, I'd like to make a PV application manager equivalent in Linux, if that's not too difficult, and if no one's done it before. There is a PV uploader program, but I think that's for uploading an LZH archive of multiple add-ins to the Pocket Viewer. Okay, a simulator program, documentation, operation manual, PV BIOS tools, and tools. Directories for respective modes are placed under the C directory. Thus, the compilation of the link operation can be complete in each directory. Okay. You can create the hex files for the compiling, linking, and updating operation by executing make.bat available for each mode. Okay, I'll have to take a look at that further. Okay, so let's also take a look at that LCC folder. See LSIJ. Yep. LS star. Okay, so there's a manual here and multiple chapters available. Let's cd bin and just take a quick look here. Wine lcc86.exe. Okay, you can see that's a cross compiler. Sorry again if that cut off for a second while I was running. Wine. Interesting. So I guess I wouldn't interact with this directly. I'd interact with it through those make scripts. Okay. Let's go back here to Casio. See what's here in tools. Hex to bin, headset. Okay, so put name. Add in a program configuration utility. Oh, wow. What's this bimp.txt? Yeah, I probably cut out for a second there. Interesting. I guess it is what it says it is. Headset. Okay. Hmm. Oh, okay, so that adds in bitmap images for the different menus. Interesting. So I guess this stuff really has to be run with Wine, since I'm not that confident I could recreate this in Linux, which is unfortunate. I'm also going to go through some examples for the Palm OS more modern Linux compatible SDK and try writing some different programs there, as I want to make the same suite of emulators, Cardiac, Evo, and Kenback on for Palm OS devices. I think that would be a very useful exercise from a lot of different perspectives. Okay, anything else I want to look at here? Yeah, I think I did put name up there. Anything else that's particularly interesting? Maybe let's take a look at hex2bin.exe. Okay, nothing too exciting there. Okay, let's go back to see if I can run the simulator. Oh, wow. Jeez. Wine sim. Now this might be really cool. Wow, that's cool. Let's just look at help. I can run my add-ins here. Geez. Project. Let's try the S450. Wow. That is really cool. Yeah, I think I might have to look at the manual there. Oh, yeah, that didn't work. Huh. Let's see if there's, okay, other programs I might run. Memory import. Yeah, I might have to look at the manual there, and that, deserves a whole video within itself. Not the simplest to use. Um, hmm. Okay, so I'll have to go through the manual there, but that's pretty nice to have that simulator provided with the SDK. Okay, close project. Okay, and we'll exit. Okay, so I think that's a pretty quick overview of the SDK. There's a few people in Mastodon I might contact to just understand this a bit better. Also look at the documentation here. Before I go, let me go ahead and look a bit further into the documentation. Um, uh, let's see if I can open this in File Explorer. Um, or maybe I'll just use Ocular from the command line. Okay, yeah, there's an instruction manual for Sim 3022. I had thought, this device had a NEC V30 processor, but the NC 3022 is based on the V30. It's a Casio custom CPU. There are some differences. Oh wow, there are probably multiple differences from the V30 CPU. So I also would bet I can't just replicate this with 8186 target based GCC. Saying directories. Wow. Wow. A lot of fun stuff in there. General items. Chips. I'll have to see if I can find more Pocket Viewer emulators. I saw one in YouTube that looked like it was Linux compatible. Source code symbol, handling add-in program related settings. Wow, that looks complicated. Oh, at this point it does. EMS, breakpoint windows, breakpoint source code level debug. Okay, so I'll have to go through that a lot further. Let me go ahead and close that and see if there's anything else to add here. Oh, that I already saw. Okay, so I'll have to read through this a heck of a lot further, especially I'll have to look at the simulator further. So I think that wraps up my quick and dirty overview of the Casio Pocket Viewer SDK. I look forward to using this a lot more in the near future. I'll look through all this documentation and some particular examples and just try and make some simple programs. And I think the cardiac paper computer emulator is probably the simplest program that I could use. So I'll work on that in the future. I think just in the next videos I'll look at more add-ins, but down the road in coming weeks and months I'll try to do some development sessions, possibly live streamed, testing out that cardiac computer emulator as well as Evo and Kenback One emulator. Okay, so with that, I appreciate your attention. I hope this was interesting and informative. If you have any thoughts, suggestions, or questions, leave them in the comments down below. And as always, thanks for watching. If you like what you see, please like and subscribe. Have a great one.